Degree of polynomial. The highest power of the variable in a polynomial is called the degree of polynomial. Steps to find the degree of polynomial. Add the powers of the variables in each term and the highest sum is the degree of the polynomial. For example, let the polynomial in two variables x and y be 3x cube y square plus 3x y cube minus 4x square y power 4 plus 7. The sum of the powers of the terms are of 3x cube y square is equal to 3 plus 2, which is equal to 5. And the sum of powers of the terms 3xy cube is equal to 1 plus 3, because the variable, if a variable or a constant didn't have any power, it means the power is 1. So 1 plus 3 is equal to 4, and the sum of the term minus 4x square y power 4 is equal to 2 plus 4, which is equal to 6. And the sum of 7 is equal to 0, because there is no variable in the term. As the highest sum is 6, so the degree of polynomial is 6. Let the polynomial in variables be p, q and r be 15, and p q cube r minus 4pq square r cube plus 7p cube q r power 4 plus 5. The sum of powers of the terms are 5, 6, 8 and 0, and the degree of polynomial is 8. Degree of polynomial in one variable. An algebraic expression contains only one variable or literal is called a polynomial in one variable. The highest power of the variable in a polynomial of one variable is called the degree of polynomial in one variable. For example, the polynomial 3x plus 7 is a polynomial in variable, and the degrees of this polynomial is 1, because the highest power of x is 1, and the polynomial of 7x square minus 5x plus 4 is a polynomial in variable x, and the degree of polynomial is 2, because the highest power of x is 2. The polynomial of 9 minus 7x power 7 plus 5x power 4 minus 3x power 2 plus 2x is a polynomial in a variable x, and the degree of this polynomial is 7, because the highest power of x is 7. Degree of polynomial in two or more variables. An algebraic expression having two or more variables is a polynomial in two or more variables if the power of the variables are non-negative, and the highest sum of the powers of all variables is each term taken as the degree of polynomial. For example, 3a cube b square minus 7b square plus 4a by b minus 3, where b is not equal to 0, is an algebraic expression but not a polynomial. Like 6x cube plus 3 square root y minus 3xy square is an algebraic expression but not a polynomial, because a power of square root y is 1 by 2, which is not an integer. Linear polynomial. If a degree of polynomial is 1, the polynomial is called the linear polynomial. For example, 2x plus 5, 7 minus 3y and 2 by 7 minus 4z are all linear polynomials in one variable and the degree is 1. Quadratic polynomial. A polynomial with degree 2 is called the quadratic polynomial. For example, 5x square plus 7x plus 2 and 9y square minus 4 are quadratic polynomial in one variable. Cubic polynomial. A cubic polynomial with degree 3 is called the cubic polynomial. For example, 7x cube minus 2x square plus 5x plus 1 is a cubic polynomial in one variable. Multiplication of algebraic expressions. If x is a literal and m and n are positive integers, then x power m into x power n is equal to x power m plus n, the product law of exponents. Multiplication of monomials. The product of monomials is equal to product of the numerical coefficient into the product of the variable parts. Like, find the product of the following monomials. First one, 5x square y square and minus 4x cube y. Here, first divide the divisions of variables and constants into two different as constants and variables, as coefficients and variable parts, which is 5 into minus 4 into x square y square into x cube y. Now multiply with which is inside the bracket, we get minus 20 into x square plus 2 into y square plus 1, because in the product law of exponents, if a same term has two different variables, then we can add the variables with the same term. So we get minus 20 x power 5 y power 3. Multiplication of polynomial by a monomial. Multiply each of the term of polynomial by the monomial. We apply distributive law. A plus b into c is equal to a into c plus b into c, and a minus b into c is equal to ac minus bc, or a into b plus c is equal to ab plus ac, and a into b minus c is equal to ab minus ac, because the term outside a bracket belongs, if in multiplication, belongs to each and every term inside the bracket. Multiply 7x power 2 y plus 4x y power 2 plus 3xy minus 4 by 5x power 2y, which is equal to 7x square y into 5x power 2y plus 4x y power 2 into 5x power 2y plus 3xy into 5x power 2y minus 4 into 5x power 2 by y. Each and every term of the first term is multiplied with 5x power 2y. Now divide every equation into consonants and variables inside the bracket. So we get 7 into 5 and x power 2y into x power 2y, which plus 4 into 5 which is x power y xy power 2 into x power 2y plus 3 into 5 x power xy into x power 2y plus minus 4 into 5 and x power 2y. Now multiply each of every term in a same way that we did in a previous sum, as 35 x power 4 y power 2 plus 20 x power 3 y power 3 plus 15 x power 3 y power 2 plus 20 x power 2 and y.